Hi, my name is Rebecca Huff, and I am in Group 1 of the Ramachandran presentations. I will be covering modularism versus holism today. I'm going to start with a brief introduction on the history of neuroscience. One of the best ways early neuroscientists had of determining what certain regions of the brain corresponded to specific functions was to study individuals with tumors or damage in those areas. These patients would then reveal to early neuroscientists how damage to those particular areas affected these certain functions. This was way before we had fMRI or PET scans or DTI. So this was kind of the only way they had to do this type of research. One such neuroscientist was Paul Broca. He found patients with lesions on the left lateral prefrontal cortex showed major deficits in uttering words but not comprehending them, a medical term deemed aphasia. From this, Paul Broca inferred that this area the left lateral prefrontal cortex, must be important in facilitating the production of words, but not the understanding. Back then, naming things that you discovered was all the rage in science, so that area was thus deemed the Broca's area of the brain. This was the beginning of modularism. Modularism was the belief that each area of the brain had one specific function, and that area was associated with that function and nothing else and couldn't do anything else. So damage to any other area of the brain wouldn't affect those functions. Now, the first individual to question a strictly localized approach was Hughlin Jackson, who proposed a more complex organization. This paved the way for others to question the localized approach as well. Localism and modularism are kind of used interchangeably in a lot of texts. Next, Carl Lashley came to a similar conclusion after a lot of postmortem dissections pointed him to a more integrated, higher order cognitive function. This new view, deemed holism, was proposed that instead of one area performing one function or task, many areas were involved, more like an integrated functional system with all the parts working together to achieve one goal. So instead of like one instrument playing, it was more like a symphony, all working together to perform that one task. fMRI has helped give us a better and more complete picture and has allowed neuroscientists to see that multiple structures may be involved in certain tasks. So definitely equipment and advancements in scientific equipment has helped us to get a more complete picture on function. Where does neuroscience stand on this issue today? It kind of pulls from a bit of both modularism and holism. Some areas of the brain are kind of known to be devoted to just that one function or certain tasks, and for other things like working memory or kind of when you're spaced out and not really focusing on anything, like the default mode network is to be one of the most famous. What we're seeing more of now is a slight swing back towards modularism, but as a whole, the consensus is more that multiple structures or networks play a part in performing most tasks, while each component in the network may have a more specific function. From my research, it doesn't really seem like they are mutually exclusive. They can kind of, both of the theories can kind of work together. Like I said in the previous sentence, there's a lot of fighting going on about this, I guess, in the neuroscience community, but I think they're both kind of right. All right, so that is the end of my presentation. Thank you so much, and I hope you liked it.